All right, so let's talk about triangle midsegments. A midsegment of a triangle is a segment that connects the midpoints of two sides of the triangle. And every triangle has three midsegments, which form the midsegment triangle. And why are there three? Because it's a triangle. We always have three. So we know because that M is a midpoint, midpoint of AB, and is the midpoint of AC, and P is the midpoint of BC because all these segments are congruent on either. Since that is all true, MP, PN, and NM are midsegments of triangle ABC. So we know they're midsegments. Well, let's look at what midsegments are to help us see how that helps us use them when we're dealing with triangles. So we know that MN is a midsegment because it says so right here. And we're going to prove that it's parallel to segment JL and that MN is half of JL. So the first thing we need to know is what are the coordinates of M and N? Well, it's a midsegment, it connects midpoints, so we're going to use the midpoint formula to find M and N. So M is the midpoint of JK, so we get minus 6 plus a minus 2 over 2, and we're going to have 1 plus 5 over 2. So we have negative 8 over 2 for our x value and 6 over 2 for our y value. So M is at negative 4, 3, negative 4, 3. Now let's find N. So N is at the midpoint of KL. So we get minus 2 plus 2 over 2 for our x, and then 5 plus a negative 1 over 2 for our y. So N equals 0 over 2, and 5 minus 1 is 4 over 2. So N is 0, 2. Now we could have just looked on our coordinate plane here and determined what that was. But what if we don't have a coordinate plane and we just have the coordinates of JKL? We need to find MN. Well, we're going to use our formulas. We're going to plug in our coordinates for x and y and find them. So now we want to determine MN is parallel to JL. Well, we do that by comparing the slopes. So let's do the slope of MN, which is the change in y over the change in x. So we get 2 minus 3 and 0 minus a minus 4. And so that's going to equal 2 minus 3 is negative 1, fourth. Now let's find the slope of not MN, but of JL. So the slope of JL is going to be negative 6 minus 2 over 1 minus a minus 1. equals, well, since I set that up upside down, that's not going to work. We got to have the change in y on top and the change in x on the bottom. So we get 2 over negative 8 equals 1 over negative 4. So Mn is parallel to JL. Slopes are the same, parallel lines. So now let's show that Mn is half of JL. And we're going to do that by the distance formula. So let's find Mn first because, well, why not? So Mn equals 0 minus 4 squared plus 2 minus 3 squared. And that's going to equal 4 squared plus or minus 1 squared. So we get 16 plus 1. Now, since I'm just comparing these to see if we've got the same number or the doubling of a number, I'm going to just leave it like that because that's a number that I can use and compare. So now let's find JL. All right. So we get negative 6 minus 2 squared plus 1 minus 1 squared. So 6 minus 2 is going to be negative 8 squared. And 1 minus 1 is going to be 2 squared. So we get 64 plus 4. Well, radical 17 and radical 68 don't seem to go together, don't seem to match, but we can reduce radical 68, see if we can find a common radical. So 68 is an even number, so I'm going to reduce it by, I'm going to divide it by 2. So I get 2 times 34. 34 is an even number, so I'm going to just keep reducing. 2 times 2 times 17. Well, 2 times 2 is 4, and that's a perfect square, so I can pull that out of the radical. So it's 2 radical 17. 2 radical 17 is exactly double radical 17. So Mn equals 1/2 of JL. Because radical 17 equals 1/2 of 2 times radical 17. So there we've gone and proved it, which is what our mid-segment theorem is going to tell us, is that the segment connecting the midpoints of 2 sides of a triangle is parallel to that third side and is half as long as that side. So if D and E are midpoints of triangle ABC, then DE is parallel to AC and DE equals 1/2 of AC, or 2DE equals AC, which 2DE equals AC is just DE equals 1/2 of AC, multiply both sides by 2 to get rid of the fraction. But by just saying it up front, puts it in the front of our mind and lets us use it a little quicker. So let's go, let's look at and let's use some mid-segments. Well, we've talked before that triangles are the strongest shape, so we use them in construction. And we use triangles in roof trusses and triangles to reinforce triangles to add even more strength. Well, segment UV right here and segment VW are mid-segments of RS. So we're going to find UV and RS. So UV is a mid-segment. It doesn't touch RT, but the mid-segment theorem tells us that it's half of the third side. So if RT is 90, so UV equals 1/2 of RT, which equals 1/2 of 90, which is going to equal 45. RS, on the other hand, is not the mid-segment. It's the third side. And VW is the mid-segment. So RS is going to equal 2 times VW, which is 2 times 57, which is going to equal 114. And in both cases, it's inches. So that is how this is going to help us find different things. And in fact, UR, since UV is a midpoint, UV is a mid-segment, U is a midpoint, so UR is going to equal 1/2 of RS. RS is 114 inches, so we get 1/2 of 114. So UR equals 57. So SU, UR, and VW are all the same size. Something to keep in mind, how that's going to work, because that can save us a whole lot of time and effort realizing that those three things have to be the same all the way around the triangle for each mid-segment. So DE and FD are mid-segments. So mid-segment, find AC and DE. So AC is equal to 2 times FD, because FD is a mid-segment, so it has to be half of AC, so AC has to be twice FD. So 2 times 4.8. 4.8 times 2 is 9.6 units. Let's find DE. DE is the mid-segment, so it's going to be 1/2 of the third side, which is AB. AB is 3.8, so 1/2 of 3.8 is going to equal 1.9 units. Super simple. Use 1/2 or 2, depending on which direction you're going. So here we're going to write a quick proof. So AE and BE are congruent. AD is congruent to CD. Show that CB is parallel. CB is parallel to DE. So D and E are midpoints of AC and AB respectively. So DE is a midsegment, so therefore CB is parallel to DE by the triangle midsegment theorem. So we have to include, anytime we're proving something, we got to show all the reasons why it's true. All right, so let's use it in a little practical matter. So let's see what we got. Let's go pink. Elm intersects Cherry Street and Peach Street at their midpoints. Actually, let's pick a little easier to see. So this is going to be true, and this is going to be true. So Elm Street is going to be a mid-segment. And we're home at point P, way up here. And we're going to go on a jog. We're going to go down Cherry Street to Oak Street, right here. Oak Street, up Peach Street to Elm, back Elm, and then back home. So what do we got going on here? So we're going to go 1.3 down Elm, down Cherry to Elm, another 1.3 from Elm to Oak, so that's a 2.6. Down Cherry Street, we're going to go all the way down Oak Street, which is another 1.4 miles. Then we're going to go up Peach Street to Elm, which is half of Peach. And Peach is a total of 2.25 miles. So we're going to do half of that. That's 1.125. We're going to go all the way down Elm Street, which is half of Oak Street, because it's a mid-segment. That's 0.7. And then we're going to come back up Cherry Street to home, another 1.3 miles. Boy, we're going further than I can run anymore. So we're going to add all these up, and we're going to find out that this is point. But it says about, so we can round it off and say we're going to jog about 7 miles. That's a pretty good run. All right, let's do it again. All right, so we're going to go, so BD intersects two sides of the park at their midpoint. So it's a mid-segment of this triangle park. And we're going to start at point A, that's where we enter the park, and we're going to go over to B, then we're going to go to BD, then we're going to go to point E, and then we're going to head back to A. So how far do we walk? Well, BC is 90, so AB has to be 90. BD is 68. DE is going to be half of 216, or 108. And EA is going to be double 68, so it's going to be 136 yards. And so that is going to equal 402. So 142 yards is how far our walk is. So 4 football fields. It's a pretty good walk. All right, so let's talk about special segments and triangle centers and create ourselves a little cheat sheet. All right, so segment joins two sides, joins the midpoints of two sides of a triangle is a midsegment. So there's M, there's N, there's a segment that connects them. Make a better N. That's what a midsegment looks like. Perpendicular bisector. It's a line segment array that divides a segment into two congruent parts and is perpendicular to the segment because it meets it at a right angle. Something like that. We do not expect a perpendicular bisector to hit the vertex of the other side. An angle bisector divides an angle into two congruent parts. Something like this. Congruent angles. If we have a median, it connects a vertex of an angle, of a triangle, to the midpoint of the opposite side. So let's do this. And we do not expect it to hit the other side at a right angle. An altitude is a segment that connects a vertex of a triangle to the opposite side so that it is perpendicular. And we know that because we measure from a point to a line at a right angle. We do not expect an altitude to bisect the side that it intersects. The circumcenter. The circumcenter is where our perpendicular bisectors intersect in a triangle. And it looks like that. And its superpower is that it is equidistant to the vertices. The incenter is where the three angle bisectors intersect in a triangle. And it is equidistant to the sides measured at the perpendicular. The centroid is where the three medians meet, where they intersect in a triangle. And its superpower is it cuts the median by 2/3, 1/3. Then there's the orthocenter. That's the point where the three altitudes intersect in a triangle, and its superpower is that it exists. All right, so now we are done.